when we talk about volume flow, especially for gases that are compressible fluids, the basis of temperature and pressure matters a lot. Today, I had a discussion with two customers in different meetings. During the morning, we were discussing about the delivery of biomethane flow to a pipeline, and I make sure that the basis for the flow measurement is 20 Celsius degree and 1 atm. This is the basis for natural gas measurement in Brazil. In other countries like Europe, if you are using the international system of units, it could be, or it will probably be 0 Celsius degree and 1 atm. And if you go to the US, eventually your system, your basis of measurement for the natural gas will be 60 Fahrenheit and 14.7 psi. So it's important to you make sure what is the basis for the measurement of gases. And another customer, another client I was discussing and it was at the afternoon, we were talking about flow of gases because he shared a spreadsheet with a volume, and he said to me that it was addressed as 20 Celsius degree and 1 atm. But when we go straight to the point, if I ask a plant to deliver a gas in normal cubic meter per hour, and I buy this plant from Europe, for instance, the temperature basis will be 0 Celsius degree. And why temperature matters too much for the measurement of gases? It matters a lot because as compressible fluids, when you change the temperature of water, you change the mass density, and depending on the mass density for the same flow of mass, you will have different values of volume. For instance, using 0 Celsius degree or 20 Celsius degree, you can have around 7% of differences in the measurement. So imagine that you design a system and you are selling a gas for the customer, and because you misunderstood on the basis of temperature, you are delivering less than the customer expects, or you are measuring more than in fact you are delivering for the customer. That is a kind of issues that you don't want to deal with in a contract. You want to deliver what the customer needs, and based on that, the profits, the revenues for your company will be okay. Some other kinds of issues that you can have with system of units is when you have short ton and you have metric ton. When you do the relationship between pounds and kilogram, it's not an exact number. So sometimes people use short ton to represent the conversion of pounds to 1,000 of kilograms. And depending on how you design your plant based on short ton or tons, that can lead to a misunderstanding, and again, you can have troubles in the contract. And another thing that I like to have explicitly in the contract is related to pressure. Because if for any reason you read in the contract that it is 10 bar to deliver to the customer, and you design your system thinking that 10 bar is 10 bar absolute, you will have the 9 bar or around that. It depends on the altitude of your plant. You will deliver your pressure 1 bar below that it is considered. Most often, the measurement of pressure in the field is based on manometric devices. So you will have the manometric the measurement of your pressure. But operations sometimes don't understand that. The businessmen that do the contract sometimes don't understand that how important is to differentiate the manometric from the absolute. So it's your duty to make sure that the system of units that are being considered of the contract is correct or not. I'm talking to you about this because currently I am a chemical process engineer. I work with plant design, but assist the business team very close. I work in the same department of the business. And my duty as the chemical process engineer, as the expert in the engineering, is to make sure that the technical parts of the contract is matching or not, if it makes sense or not.